Okay, hello everyone. This is Salar and we are in part 18 from our tutorial, a tutorial to writing a real-time operating system. And as I said in previous part, in this part I wanted to start talking about assembly programming and computer architecture. So, yesterday I bought new microphone and I think in this part and from this part I will have better voice quality. Anyway, let's get down to our business, talking about assembly programming. Why assembly programming and why do we need to write code with assembly programming? In assembly programming you have some advantages. For example, when you write your code in assembly language, you have more access to hardware. Okay, one of the advantages of assembly programming is you have more access to hardware. And another advantage is with assembly programs and assembly code, you can write more efficient codes. Okay, you can write more efficient programs. For example, assume that you want to write a more efficient code for context switching in your operating system. Okay, I will talk about context switching, but context switching is a bottleneck of operating systems. Okay, and with assembly programs and assembly code, you can write more efficient codes in critical parts and bottlenecks. And another advantage is with assembly programming, and when you learn writing a code with assembly, you will have a better understanding about your hardware. Okay, it can help you to find better understanding about your hardware. But until now, we have written our program in high-level languages like C in our tutorial. But let's open my note, my digital note. As you know, there is some high-level programming language like C, C++, or other languages. Okay, and you can write your program with high-level languages. But there is some other low-level languages. Low-level language, and one of low-level and lowest level languages is machine code. What's machine code? A series of 0 and 1, like 1 0 1 1 0 0 1 1 1 0. Codes like this, okay, and known as machine code. And your computer and your processor just understand and just comprehend machine code. Okay, your computer just comprehend machine code, and with compiler we can convert our high-level language and high-level codes or program to machine executable codes. Okay, with compiler we can convert our program in high-level languages to machine code. For example, with ARM-GCC. But early programmers in early computers, for example in 40 and 50 decades, okay, had to write their code in machine code. Okay, had to write their code in machine code because there were no high-level languages those years. Because of that, some programmers and computer engineers decided to create assembly languages, and assembly languages were developed. But what's the advantages of assembly languages? Assembly languages have these features, and one of the most important features is assembly languages are more human readable than machine code. Okay, more human readable than machine code. For example, you can write your code with some commands and instructions like add, jump, and sort of things, okay, instead of 0 and 1. And assembly instructions are directly convertible to machine code, okay. For example, in ARM processor, if you want to see the instruction set and assembly code of your processor, you can download a PDF from ARM website, ARM architecture reference manual for your architecture version, okay. ARM architecture reference manual for Cortex-M, for example, Cortex-M, okay. Search for this and you can download ARM version 7 M architecture reference manual, okay. A manual about ARM architecture, ARM version 7 and M, Cortex-M microcontroller, Cortex-M processor, okay. You can download it, but I've downloaded this file and I have it in my computer, okay. ARM version 7 M architecture reference manual, and this is so important manual for us. And for example, you can see your instruction and your code in assembly program in this manual. You can find them here, okay. For example, go to this page, for example, an instruction for adding two numbers, okay. And as you can see, you can convert your instruction to a fixed number machine code, okay. So assembly codes and assembly instructions are directly convertible to machine code, a fixed size object code and machine code, okay. Another feature is assembly instructions and assembly language is architecture specific, okay. Is architecture specific. For example, assembly language of x86 is different from, for example, ARM or MIPS, and in each architecture you will have a specific assembly language, okay. And if you want to write an assembly code for your computer or for your laptop, you had to learn about x86 assembly language. If you want to write an assembly language for your microcontroller, you had to learn about ARM assembly languages, okay. But let's get familiar with instruction set in ARM, okay. Instruction set in ARM, as I said, if you want to see the instruction set and information about your processor, you should download this manual, okay. And in table of contents, in chapter A4, you will have ARM version 7 instruction set, okay. And in this chapter and other chapters, okay, you can find a lot of information about your processor and instruction sets and assembly programs. For example, you can go to this page and you can see all of your instructions in ARM Cortex-M version 7, ARM version 7 architecture Cortex-M, and you can find all of instructions in these processors, okay. Here in ARM version 7 M architecture reference manual. Okay, how can I write an assembly program, and how can I write my project in assembly, and how can I configure my program, and what's the minimum configuration for writing an assembly program? Okay, for that, first open Eclipse. And before start coding, first go to your workspace project, go to your project directory, first Eclipse. I've created that in previous parts, and I want to write my main function in assembly. So delete your C file and create another source file. For example, main, but in this time with .s suffix, okay, for writing an assembly program, an assembly code. Okay, open your project and open main.s. To find that, right click on your project and refresh the project. Okay, I have main.s here. So to write an assembly code, you need to add some directives in your code. Okay, directives is a string for doing some configuration in your code. Okay, first directive is .syntax. Okay, .syntax and unified. Okay, .syntax unified. What does mean .syntax and unified? It creates some compatibility between earlier ARM processor and Cortex-M, but I will talk about that in future parts. Okay, so you need to add this directive .syntax unified in your code. Okay, after that, like a C program, you should define main symbol. Okay, like main function. How you can define a symbol? With name of your symbol and a colon. Okay, you need to define main in your file, and for this symbol you need to add a directive. What's that? Global and name of your symbol. Okay, what's that? Globe.l and main. Introduce the main to linker. Okay, it's so important, and you need to introduce your main symbol to linker. But in C programming, compiler will introduce main to linker automatically, but in assembly programming you need to add this directive in your code. Okay, you need to add this directive in your code. You need to add main symbol in your code and introduce it to linker. Okay, and in the end of your file, it's better to define end directive. What's end directive? End ignore all content after end. Okay, for example, if you add a content or text after end, for example, add hello world. Okay, hello world is not a instruction or label, just is a comment. Okay, just is a simple string, but because it is, and this string is after end, your assembler will ignore this string. Okay, if you compile your code and build your code here with this icon, now you have no error. But if you comment this line, you will have an error, bad instruction, hello world. Okay, but all texts after end will be ignored. Okay, here is my main function, a contentless function, but I want to create a loop here. Okay, with branch string. instruction. I will talk about branch in future parts, but with branch you can create a jump to main. Okay, branch to main, branch to main, branch to main. It's a loop in my code, and my project has been built. Okay, now I can debug my project. Click on this button to debugging, and here I'm in debug perspective, and as you can see my code is in the first line of main function. And if you run your code will be stay in line 4 because I have a loop here. Jump to main, branch to main. Okay, and I can see all of my registers and breakpoints and disassembly, for example, like in C programming. Okay, now in this way, with this directives, I can write a simple assembly code. But before to starting write a real and more practical assembly program with assembly instructions, let's get familiar with registers. Okay, with registers in processor. What's a register? In C programming, okay, you can save and keep the values, in variables. For example, you can create a variable like here and put a value in that. Okay, in C or other languages, high-level languages, you can create variables and save your values in them. Okay, but in assembly programming you can save your values in registers and main memory. I will talk about main memory in the next part. Okay, but in this time I want to talk about registers. In ARM we have some important registers. The name of those registers is from R0 to R15, and these are 32 bits registers. Okay, 32 bit registers. R0 to R12, known as general purpose registers. But R13, R14, and R15 have some special usage. Okay, special usage. R13 known as stack pointer register, R14 known as link register, and R15 known as program counter register. But we can use R0 to R12, the 13 registers, for general purpose and use them as a operand or result in our instructions. Okay, as operand or results in our instructions. For example, for a simple instruction, okay, for first instruction that I want to talk about, that for Let's go to page 1, 2 here. For example, for add instruction, with this instruction add, you can add two registers and put the value in registers to another registers and put the value in another registers. Okay, for example, with add is an instruction, assembly instruction for R. Okay, to adding two number, you can add two registers and put the value the result registers, like here. With this instruction, you can put the value of R2 plus R1 to R3. Okay, R3 equal to R2 plus R1. Okay, and similar code in C, for example, is C equal B plus A. Okay, if you want to add two number and put the value in another variable, you can use this instruction. Or for example, with add, you can add, for example, R2 and R1 and put the value in one of these operand registers. For example, put the value in R2, like C. Similar similar command in C, for example, is B equal to B plus A. You can register, you can sorry, you can use a register in operand and in result. You can like this, or you can add your register with a constant number. For example, R1 equal to R1 plus a number, for example 10. Okay, if you want to write a constant number, you need to add this hash sign in front of your number. Okay, and this constant number known as immediate value. And the similar code in C, for example, is A equal to A plus 10. Okay, as you can see in architecture reference manual, you have an add instruction that you can add Rn plus Rm and put the value in Rd. Summation the value of two register and put the summation and result in another register, or in add immediate, you can add a value of one register with a constant number immediate. Okay, I will talk about this S. I will talk about S later. Okay, here you can add a register with a constant number and put the result in another register, or for example this register. Okay, you can repeat a register in input and output of an arithmetic operation. Okay, like here, R2 plus R1, the value, the result in R2. So let's write a code, for example, with this instruction. Delete this line and, for example, add this line, add, and R3, R2, and R1. Okay, or for example, add in another way. For example, you can add a R1 with a constant number and put the value in R1, 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 and a constant number, for example 100. Okay, this immediate number should be less than this number. This immediate, the maximum value of this immediate can be a 16-bit number. Okay, 16-bit number. Okay, and after that you can create a loop like here. If you want to create a symbol, okay, another symbol than main, okay, for main you just write just main, but for another symbol in your code you should write dot capital L in the first of your symbol. Okay, in the first of your symbol. This rule is true just for those symbols except main. Okay, except main. For example, dash L and here and a column. Okay, here I have a symbol. To add a local symbol or local label to your code, first you should add dot L in the first of your symbol. Okay, and like before, branch to dot L here. Okay, and here is a loop. Okay, jump to dot L here, jump to dot L here, and let's do compile and build my project. Let's build my project and debug that and run your debugger. Okay, as you can see, we are in the first line of main function. Okay, and let's do see our registers. We have a lot of registers in ARM Cortex microcontrollers, but in this time I want to just talk about R0 to PC. Okay, R0 to R15, these registers. If you run the first of your line, you will add the value of R2 and R1 and put the result in R3. As you can see, the value of R1 is 0, the value of R2 is 0, but in this time the value of R3 is here. Okay, let's do run the first line. Okay, as you can see, the value of R3 in this time is 0. Okay, 0 plus 0 is 0. And for this line, add R1 with 100. I want to add 100 with the value of R1. The value of R1 is 0. And if I run the line, the value of R1 in this time is 100. Okay, I can add the value of a register with a constant number, and I'm in my loop. Okay, if I run my code, I'm in this line because this is a loop. Okay, infinite loop. Okay, stop the debugging and back here. You should get used to study this reference manual and instructions by yourself, and for practice, study about some other instructions. For example, study about sub instruction for subtracting two numbers. Okay, and to do a logical operation or other instructions like this. Okay, you should get used to study reference manual for your work. Okay, and for practice, try to study about these instructions by yourself. Okay, but we have some other important instructions, and instructions are move W and move T. What's this instruction? With move instruction, you can put a value of an instruction to another instruction. For example, with an instruction like here. You can put the value of Rn to Rd, okay? Or with move and move t, you can put a constant number to a register, okay? You can put a constant number to a register. For example, assume that here is a register, a 32-bit register, and assume that your register has two parts. Low part from bit 0 to bit 15 and upper part from bit 16 to 31, a 32-bit register. Lower part, upper part. With move W and an instruction like here, you can put a constant number. This constant number should be 16 bits, okay? The maximum of this constant number should be 16 bits. You can put this 16 bit with move W to lower part of a register, and with move T and another time a constant number that the maximum value is 16 bit, you can put this 16 bit to upper part, okay? And another move instruction is move negative, and you should study about by yourself from reference manual, okay? I want to just talk about move W and move T, okay? Let's talk about this by these instructions. For example, assume that in this time I want to move the value of R1, for example, to R4, okay? R1 to R4, okay? Or for example, assume that I want to write a constant number to register R5, okay? For lower part, use move W, R5, and a constant number. For example, a hexadecimal number 1111, okay? In lower part, and move T for upper part. Another time in R5, and for example 5555, okay? I want to put this number for lower part and this number for upper part. Let's build my project and debug that. Okay, now let's run my code to line 7 here, create a breakpoint and run code. Okay, I'm in line, reset my code, run to line 6. Okay, I'm in line 6 and I want to transport the value of R1 to R4. Okay, the value of R1 is 100, but the value of R4 is 0. If run this line, the value of R4 is 100. Okay, if run line 7, move W, this number to R5, the value of R5 is 0. But if run this number, now the value of R5 is hexadecimal. The hexadecimal number is 1, 1, 1, 1. Okay, this number. And if I run the line number 8, now it's the value of R5. Okay, the upper part and the lower part of register. Okay, in this way I can put a number in a register. I can put a constant number in a register. So here was some simple instructions to write an assembly program. Okay, but let's to give you an example. As I said, our registers are 32 bits register. Okay, 32 bit registers, but assume that I want to add this number f f f f f f f f with 2. Okay, assume that I want to add this number with 2. The value is 0x00 1 plus a carry. Okay, I will have carry. Or for example, for a signed number, assume that I want to add these two numbers. The value is, the result is this number, and I will have overflow. Okay, overflow. So how can I find and how can I realize that a carry has been happened? Okay, a carry take place in my operation. How can I find? For find this sort of things, you can see the value of APSR register. Okay, APSR register. To see that, open the reference manual and go to this part. Okay, part A232. Okay, the application program status register. This register gives you some information about your arithmetic and logic operations, and these bits are important for us now: N, Z, C, V. But in this time, Q and G is not important for us. Okay, what's N? If you have 1 in bit 31, it means that the result of last operation was a negative number. Okay, N means negative. What means that? Means that the result of last instruction was a 0 number. C means in the last instruction carry has been happened. Okay, and V means overflow has been happened. Okay, so how can I update this register? Okay, how can I update this register? For example, if you want to update this register after an add instruction, you should add S in front of your instruction. Okay, as a suffix. Okay, if you add S, for example, RD, RN, and RM, the value of APSR will be updated. Okay, the value of the APSR will be updated. You can refer to reference manual and go to instruction sets, for example, here for adding, and as you can see, I can use S in add instruction. Okay, if your instruction has this option, with this instruction you can update APSR register. Okay, you can update APSR register, for example, and in this time you have add S or add. Okay, and for example, you can see in another operation, for example, here, for example, for a logical shift operation, you can use S in your instruction. Okay, if your instruction has this option. You can update ASPR register with this instruction. Okay, let's do an example. Let's do delete lines, and for example, assume that I want to write f another time 0x this number in register 5, and I want add register 5 with 1. Okay, with, for example, R5 with number with 2. Okay, let's build my project. And run debug. Okay, first run line 5, run 4, line 4 and 5. Now the value of register R5 is here. Okay, the value of register R5, and I want to add it with 2. Okay, and as you can see, the value of X, why here is XPSR, because this register now is collection of 3 registers, ASPR, ISPR, and ESPR. But in this time, I want just talk about higher 4 bits, okay, highest 4 bits for negative, 0, carry, and overflow. Okay, but in this register you can find other information about other happens in your processor. Okay, but let's run this addition instruction. After that, as you can see, the value of ASPR is 2, 1, and other, and this 2 is important for us. Okay, 2 in hexadecimal means 0, 1, and sorry, 0, 0, 1, 0. Okay, 0, 0, 1, 0, and 0 is negative, another 0 is Z, here is carry, and last is overflow. And this means that we had a carry in our operation. Okay, we have had a carry in our operation, as you can see here. Here is carry. Okay, as you can see, I've had a carry in my operation. Okay, and in this way you can update ASPR register in your program. But enough for today talking about assembly programming. But for a practice, you can study about ADC, add with carry instruction, and with this instruction and other instructions you can write a code that multiply the value of, for example, R2 by R1, multiply R2 and R1, and put the value in, for example, R5 and R4, because if you add two 32-bit number, the result is 64-bit. Okay, and you need 2 registers to save the result. You can write a program with add with carry and other operations and other instructions, and write this practice, and it can help you to increase your ability in assembly programming. Thank you very much, and see you soon in the next part.